It's a couple of, actually -3 degrees elevation before the sun pops up over the horizon. It's a very overcast day, so unfortunately we're not going to be able to see where the sun's coming from. But here's my completed solar panel mast. I've got to adjust the frame up the top because the solar panel's a bit on the arse. But having said that, I completed all the firmware last night for the Arduino boards. There's my display screen, which is unfortunately not very visible in these conditions. The elevation of the sun is now -2 degrees, so what I'm going to do is I'm going to raise the mast using the Arduino control panel. So the mast is now on its way up. Takes about a minute or two, and then I'll start the program, and the program will effectively wait until such time as the elevation becomes a positive, until such time as the software determines that the sun's above the horizon, and then it'll move the azimuth and elevation to make the panel face towards the sun. So we'll hopefully get that down on video in just a short while. The panel was originally designed to, the mast I should say, was originally designed to go on the back of my caravan. Hence it's raised 800 millimeters. It could eventually wind its way back there and the panel be permanently mounted onto the back of the caravan, but the issue I have at the moment is that I'm not comfortable with the strength of the frame that actually rotates the panel on its elevation as far as it being able to withstand wind as I'm travelling along the road in the caravan. So it is what it is at the moment. At the moment it's just going to be the elevation and azimuth assembly is going to be removed from the top of the mast once I'm driving around. So basically the only thing that will remain permanently mounted onto the caravan is the mast mechanism, which I can show you at a later date. So we're now still -2 degrees below the horizon. The functions have just indicated that we've completed raising the mast, and that's now indicated by a green arrow that you can't really see here, but if we go back into the functions menu, we now have an option to lower the mast or start tracking. So I'm going to confirm tracking, and it's not going to do anything at the moment because the algorithm has determined that the sun is still below the horizon, so there's nothing to do. So yeah, I've just thought of something that I need to change the firmware, but that's neither here nor there. What it does do though, at the end of the day, when the sun has reached the end of its travel through the sky for the day and it goes below the horizon, it'll automatically park and lower the mast at the end of the day to make sure that it's sort of in a semi-protected state in case the winds pick up during the night or whatever. But it's obviously something you'd need to keep an eye on, because I don't know how sturdy the panel up that high would be on such a slender pole, but we'll wait and see. Okay, we're still -2 degrees elevation. Azimuth is 81. The panel itself is facing 180 degrees from north. So the reason for that is that I need a reference point to start with. So when the panel rotates, it typically only rotates at a maximum of around 180 degrees, but I've got to make sure that the elevation cables, which you can't really see through the trees up here, these cables here don't get twisted around the motor assembly. So what I've done is I've had to make an arbitrary decision that I've got a starting point of 180 degrees from the linear direction of the actual caravan, i.e. it's facing towards the front of it's facing towards the back of the caravan all the time. So that way, as it rotates, if the software determines that the cable is going to be wrapped up around the motor as a consequence of getting to the angle it needs, it'll actually turn the whole panel around the other way, so it actually unravels the cable and then points the panel in the correct direction again without actually rattling all the cable up. Still -2 degrees elevation. Normally it takes about 3 minutes between each. There we go, it's just clicked over to -1. So what we'll find in a minute, as soon as the elevation is 0 or greater, the program will physically start. So at the moment it's -1 degrees, and again it takes about 3 minutes for the elevation angles to change. Similar with the azimuth angles. In actual fact, I think the azimuth angles are a little bit shorter. But at the moment, the azimuth is 80. If you look at the panel at the moment, the panel is actually facing 180 degrees from north. So 80 degrees effectively means, well, you know, close to 90 degrees. The panel is going to make a close to 90 degree turn to the right to face the morning sun, which is to our right in this video. And it'll actually be a little bit more than a 90 degree turn, because at the moment the azimuth is 80 and the panel will subsequently rotate 90 plus 10 degrees to get to the required 80 degrees azimuth that I'm after. So, rebel, I'm just going to keep yakking here until such time as the elevation comes up to 0. There's just a couple of things I would like to do with the firmware at this stage, and that's to have a function on there to actually adjust the angle on the motors in case you have to turn them off and the motors are stuck in the position that they're in. Particularly with a mast motor. The mast motor is a motor that locks the motor once it's turned off, which is why the mast motor is a very suitable motor for the one I've got it working on. If the power is not applied, the mast motor just simply, you can't rotate the shaft. Whereas these motors here on the the azimuth motor and the elevation motor that you can see inserted in that shaft, you can move them, but I won't do that. They can rotate. So, yeah, we'll very shortly hopefully see this sucker start moving. What are we now? -1. Video's been running for 7 minutes and we were -4 elevation when we started, so we're down to -1. I reckon we'll be rotating very, very shortly. It's probably a good thing I can talk with a mouthful of marbles underwater to keep this video running in the same time, but yeah, some of the functionality on the panel is we can adjust the offset for, like if you enter in the heading that the vehicle is in incorrectly, or your heading, your reading is slightly off, you can adjust the azimuth angle, and you can also, if your caravan's on a slant or something like that, you can also adjust the offset for the elevation as well. Obviously, only in a positive. To a positive angle, not a negative angle, because it's physically stopped from going any further down in a negative elevation by virtue of the fact that it's stopped by the mast from actually going that way any further. Okay, where are we up to? We're up to -1 elevation still. It will be any second now. I originally had what are they, LM5338 compasses on here, so I didn't have to take a heading, but they were just proving too cumbersome to actually use. I've used Anderson power pole pack connectors, which are fan-friggin-tastic for getting all your connections done. That's a 10 pole, that's a 6 pole. The 6 pole runs to the mast mechanism, which has got 2 proximity sensors on it and a DC motor, and the mast mechanism runs to, the 10 pole runs to the top assembly, which has 2 DC motors, 2 rotary encoders, optical rotary encoders, and here we go. Right, we've now reached 0 elevation, so the sun's just basically now reached the horizon. So the panel is now rotating to the correct the elevation angle's already done its bit. Now the panel's rotating to face the panel towards the sun, which should be just 10 degrees. There you go, 10 degrees shy, 10 degrees positive of 90 degrees from where we're sitting at the moment, i.e. 80 degrees. So as you can see, that's pretty well facing north as I'm facing the camera, and the panel is about 10 degrees off. So very happy with that. So what we do now is, if we want to stop the program, we select our function, we stop tracking, select the function again, and we say lower the mast. So what happens now is the panel now goes back into a park position. And what I'm noticing is that I'm not getting enough power to the motors, so I'm going to actually have to change the firmware on this. The firmware at the moment is set to a pulse width modulation value of 255 for the elevation and azimuth motors, but I can go up to, because these are using the analog inputs on the Arduino, it effectively means that I'm not putting full power into the motors, and that will be, to a degree, something that I need to be able to adjust out in the field, because the torque on the motors will be affected by things like wind and the like. So if the panel's blowing around, then I'll need to adjust the amount of power going through the Arduino to the motors to make sure that it's not affected by wind. And as I just found out then, just for the simple case of trying to rotate the motors, it wasn't able to do it simply because of the weight of everything here on the azimuth motor gear train. So what I'll do is I'll lower the mast now, I'll take the Arduino back inside, I'll reflash the firmware with a higher value for the pulse width modulation values for the azimuth and elevation motors, and hopefully get a bit more torque out of the motors. These are all the deep groove bearings for keeping the mast centrally located. There's linear bearings for CNC machines, and linear tracks for CNC machines for the purpose of raising the mast. That's it for now. I'm going to go in and make an adjustment to the firmware, and we'll see how it goes after that. Thanks for watching.